Good morning to all. In this seminar, we will learn about what is apparent depth and their derivations. We notice that when we see the bottom of the water surface from the top angle, the bottom surface is slightly elevated. The distance from the surface of the water to the elevated point is called apparent depth. Now we derive the expressions for the apparent depth. Consider a water tank filled with water of refractive index N1 and the air medium has the refractive index of N2. The light rays coming from the bottom of the surface, that means the point O, when reaches the point B, it deviates away from the normal. The normal N and N dash is parallel to the OD. The distance from D to O is actual depth and that is mentioned as D, and the distance from D to I is mentioned as D dash and that is the apparent depth. The I is the angle of incidence and R is the angle of refraction. We know the Snell's law, that is N1 sin I equal to N2 sin R. As the angles I and R are very small, we take sin I equal to tan I and sin R equal to tan R, and the equations becomes N1 tan I equal to N2 tan R. In triangle DOB and DIB, we obtain tan I equal to dB by DO and tan R equal to dB by DI. Apply the two values in the Snell's law. We obtain N1 dB divided by dO equal to N2 dB divided by di. Cancel the dB on both sides and apply the value dO equal to d, that is actual depth, and di equal to apparent depth, that is d dash. We obtain N1 divided by d equal to N2 divided by d dash. Rearranging the equations, we obtain d dash divided by d equal to n2 divided by n1. We need the apparent depth, that is d dash. So we change the equations and we obtain d dash equal to n2 divided by n1 d. Suppose we need how much the water is elevated from the bottom of the surface. We minus the apparent depth from the actual depth and the equations becomes d minus d dash equal to d minus d by n.